Hello everybody, this is Dr. Sandeep Jagani. Today we are going to take a look at forecasting. Specifically, we are going to take a look at a math problem in forecasting. This is the problem number 22 on page 438 of Jacobs and Chase textbook, 15th edition. It reads that your manager is trying to determine what forecasting method to use. Based upon the historical data on the next slide, calculate the following forecast and specify what procedure would you utilize. In this, we have to calculate 3-month moving average from 4 to 12 period. We have to calculate weighted 3-month moving average with the weights 0.5, 0.3 and 0.2, and then we have to use a single exponential smoothing forecast for period 2 to 12. Initial forecast is given 61 and alpha of 0.3. Later, then we have to calculate in part D exponential smoothing with trend component, and the forecast for period 2 to 12 and trend forecast T1 is given as 1.8 and initial forecast is for F1 is 60 and alpha is 0.3 and delta is also 0.3. Finally, you have to calculate MAD for each of the method that you have used from A to D, which is the forecasting method that you would prefer. MAD is nothing but mean absolute deviation, or it is the mean of how much your forecast is away from your actual occurrences. Then we have historical data from month 1 to 12, some formulas that we might use to calculate the forecasting using those methods. Let us copy this table to a blank Excel spreadsheet and then take it from there. Here is an Excel spreadsheet. I'll be moving little faster in this problem, and you can pause the video whenever you require to take a deeper look at any formula or need some more time to understand any concept. First, we'll do the simple moving average. We can only do it from the period 4 because the moving average is nothing but average of previous 3 periods. Average of previous 3 periods, hit enter, we get the average of 3, 2 and 1, which will be the forecast for the 4th period. We can hold the corner and drag it until the 12th period to get the forecast of all the periods from 5 through 12. We know that we have to calculate mean absolute deviation in the part E of this problem. That's why we are going to keep calculating mean deviations or mean absolute deviation of each of these method as we do it. So deviation equal to absolute value of whatever was actual minus whatever was forecasted, and then if you drag it through the last, that's the media of all of them. We can take an average of all of that, that is mean absolute deviation of this method. Same way we can calculate weighted moving average. Weighted moving average as is given in the problem. The weight of the most recent period is 0.5. Next most recent is 0.3, and the third furthest period is weighted as 0.2. And then you drag it through the end. We can calculate the deviation as we did in the previous method. The formula will be remaining same, that is what happened in actual minus how was it forecasted. I want to freeze the column because if I copy the formula here, I want to make sure that this column stays the same. So I will put a $sign before B that will enable me to freeze this column B. I hit enter, and now what I do is I just hold any corner of this highlighted cell and hold control and drag it through where I want to copy. Now you'll see that because we had a $sign before column B, that remained the same while this was changed to G13. And now hold the corner and go to the end. I can do the same thing. I don't need to freeze anything here. I'll just hold any edge and then copy. Now you see that MAD is 3.4556 for the weighted moving average. Next, the third method that we want to see here is exponential smoothing. In the method exponential smoothing, we'll first look at the formula. If you look at the formula here, the exponential smoothing formula says ft, or the forecasted period's forecast, will be equal to ft minus 1 plus alpha times what happened actual minus the forecasted, which is how much is the deviation for the previous period forecast. So you are multiplying a smoothing factor alpha with whatever was the deviation in the previous period, and then you add that to the previous period's forecast. That's the formula here. That means if we want to forecast for any period, we need the forecast for the previous period as well as we need what happened actually on the previous period. Now for this particular problem, if you look at the question, it says that the initial forecast is 61. So ft minus 1 you can take as 61. But what if this was not given to you? If this was not given to you, you can use the regression's intercept, y-axis intercept as your initial forecast, and when we do the regression method, we'll take a look at it. Okay, so the first period is given as 61. From the next period onwards, you want to do a forecasting. So again, the formula, we have to see that whatever was the forecast for the previous period, you add the smoothing factor alpha, which is 0.3, and you take the difference between whatever happened in the actual minus whatever was the forecast. Again, that 0.3 that we used here, the selected number, that is nothing but the alpha. Hit enter to that, drag it through the last. We have that exponential smoothing forecast for all the periods from 2 through 12. What we can do is we can copy these deviation cells into the fourth deviation. Since we are comparing apples to apples, we'll only use the deviation from the period 4 to the 12. MAD, we'll copy that, hold any edge of that selected cell and move it to the last. So that's MAD. Now before proceeding any further, we want to see whether these numbers and MAD make sense to us. Alright, so we have three methods: simple moving average, weighted moving average, and single exponential smoothing. In this, we see that we have calculated MAD. One was 4.07, other was 3.45, and the third was 6.174. Method that gives you the smallest MAD should be our preferred method to forecast. So using these three methods, we are seeing that MAD for weighted moving average was 3.4. So that's our preferred method. If we are only given choice to use one of these three forecasting method, we would rather use weighted moving average as our method. But on a graph, how would it look like, or why we see that the method with a lower MAD should be a preferred method? Let's look at the graph. We will select the data which we want to plot, then we'll go to insert and then insert a graph of the data. Now you see that it has a continuous trend of increasing, and then there are a lot of space here. We'll just make sure that we'll just remove these all space because we don't need those spaces here. So I need everything from 60 and upward, so I'm just going to delete them. So if I double click the axis and then go to y-axis from 0 to 90, I'll just keep it 60 to 90. Alright, so all other things which we did not need are now not being shown. This is actual data, but let's put some legends over there. Click the graph, go to the add element, and then go to the legend where you want the legends. I'll just keep the legend on the right of this. Legends are nothing but what color stands for what kind of forecasting or what curve. With this, we want to add our three forecasting points that we have, three sets of forecasting points that we have. So now we are going to add data to this. So right click, select data, add, series name. Series name is simple moving average, and series values will be including the empty cells until the last one, and click OK. So now you see that the orange curve here is the simple moving average forecast. You add one more. next one will be weighted moving average, and that weighted moving average, you do the same thing, including the empty cell until the 12th row. You copy it. The gray line, you see, that's more closer to the blue curve. And finally, the exponential smoothing curve, you will add one more exponential smoothing and equal to everything from 1st to the 12th. Click OK. If you look at this yellow line, that's too far away from this blue curve. That means this is obvious because the MAD is the highest for this. Click OK. And now you have these three curves here. What we want to do is we'll continue this problem with exponential smoothing with trend. We'll also see how would a method like regression fit to that, which is not asked in the question, but we'll still do that. An upward or downward trend in the data collected over a sequence of time period causes the exponential forecast to always lag behind. That means be over or below the actual occurrence. Exponentially smooth forecast can be corrected somewhat by adding in a trend adjustment. To correct the trend, we need two smoothing constant. Besides the smoothing constant alpha, the trend equation also uses a smoothing constant called delta. Both alpha and delta reduces the impact of the error that occurs between the actual and the forecast. If both alpha and delta are not included, the trend overreacts to the error. Let us go back to our slides and look at that equations for computing forecasts including trend. If you look at this second sets of equation, exponential smoothing with trend, ft or the forecasting period or forecast of period t equal to fit minus 1 t minus 1 plus alpha of actual t minus 1 minus fit t minus 1. In this fit means forecast including trend. So we need a forecast including trend of t minus 1 to calculate the forecast for t. And what we do with this t? We also use a trend for the time t, where tt is t of t minus 1. That means the trend of the previous period's forecast plus the delta times forecast ft minus fit t minus 1. And then you add ft and tt together to get fit. Using these three sets of equation, we are going to calculate exponential smoothing forecast for the periods 2 to 12 with trend. For this, we are going to make three columns. In fact, four. First is for the trend, second is for the forecast, the third is for fit, forecast including trend, and the fourth is for deviation. Usually we are given the trend t and also we are given ft, which is the initial period's trend and initial period's forecast. If we are not given, we know that ft can be found out by the regression line's intercept of y-axis. If tt is not given, then that is nothing but the slope of the regression line you can use. In our case, we are given that tt is 1.8 or t1 is 1.8 and f1 is 60. So we are going to use those numbers. On this side, I am keeping the equations for the exponential smoothing with trend for ft, tt and fit. For fit for the first period is nothing but the addition of ft plus tt. For the second period, we will first calculate ft and then we will calculate tt because tt uses ft here. So ft will be equal to fit minus 1, so that is this, plus 0.3 times actual t minus 1, which is this, minus fit minus 1, which is this. And then tt will be equal to t minus 1, tt minus 1 plus delta is also 0.3 times ft, so which the one that we just calculated, ft minus fit minus 1, and then FIT's formula remains the same. We can select all these three cells together and drag it until the last period, 12th period, and now we have the exponentially smooth forecast with trend included. We can calculate deviation, hold control, select any cell, pick the edge and drag it to where you want to copy. And now you can see that your MAD for the last one is just 0.89. Now we will insert the fourth exponentially smooth forecast including trend to our chart that we have created. So right click, select data, add, series name is exponentially smooth including trend, and then use all of that. Click OK. Click OK. FITT, you see this blue line, which is much more closer to the actual line. That means our forecast is more accurate. And that can also be reflected on the value of MAD, which is just 0.8946. So as far as this question or the scope of this question is concerned, we have done forecasting using 4 different methods: simple moving average, weighted moving average, exponential smoothing, and then with trend correction. Looking at all this method, the method with the minimum MAD is the one that you would prefer. So your method with exponential smoothing forecast including trend is the one that you would prefer. But let's take this to a step further. If you were asked to calculate forecast using linear regression, how would we do that? Remember, linear regression is defined as a functional relationship between 2 or more correlated variables. It is used to predict one variable given the other. In this case, our 2 variables are, one is the time and the other is the quantity or the demand. So if we are asked to calculate the forecast for 13th period or 12th period, what is that going to be? So first we have to identify the equation of the regression. Let me zoom this figure. As you can see, the dark blue is the actual data. So I changed the color of the exponential smoothing line including the trend correction. I changed the color so that we can completely differentiate it between the actual data and the FITT. So now if you look at this blue line, and if I want to draw a regression line to that, I can right click that and add a trend line. Adding a trend line, the dotted line you see here, that is nothing but the linear regression line. So equation of that line will be here, display equation. You have the equation y equal to 2.0594x plus 6053. Remember, our x is nothing but the periods and y is nothing but the demand. So we'll be putting all the values for our periods x in this equation to get y. So let us create another 2 column. One is for the linear regression line points. Other one is for the deviation. I'm going to put this figure away, and then I'm going to have 2 different columns. LR stands for linear regression. Deviation is the difference between actual and the predicted value. In the column LR, our equation is 2.0594 x. X for us is period plus the constant is 60.53, and you can drag this to the end, and let's look at the last number. So last number is 2.0594 times 821, which is the period 12 plus the constant or the intercept. Deviation we'll only calculate from the 4th because we want to compare it to the other method, and as you can see, We copied that cell and it took the right cells. Alright, so this gave us even lower MAD, and if we want to plot that to this graph, we will add data, add LR stands for linear regression, and then all of these points you select, click OK. So you see that the green line you see here is nothing but the regression line. So I changed the color of this linear regression line. The black line that you see, that is nothing but the linear regression line. Definitely that coincides with the trend line that we plotted for the actual demand. So the moral of the story is that the minimum MAD is our preferred method. In this case, we see that since this is a continuous upward trend, we are seeing that the MAD of the linear regression is the minimum, and we will always prefer to use that method for our forecasting. So that's all for this problem. If you have any question, concern, please feel free to email me. Have a great day. Bye-bye.